Students, after seeing this application of integral and differential calculus, let us understand these three laws according to them. First, the second law, which says that the rate of change of linear momentum is directly proportional. This is the word important to the applied force. So let us write it like this. The F is directly proportional to dp dt. That means it is dp dt is, we know that P is the linear momentum which is equal to mv. So ddt of mv, m being a constant, will come out, and ddt of v, which is nothing but ma. Now F is directly proportional to ma. In order to remove this proportionality, I have to introduce a proportionality constant, say k. So F is now equal to kma, where k is 1. So finally F force is equal to ma. This is the discussion on second law. Second law. Now remember one thing, while you will be doing problems, keep one thing in your mind, that this F is external and net. The total force is equal to ma. Now, this was the second law discussion on second law. Let us now understand the first law. The first law. This was second law. Wait a minute. This was the discussion on second law. Second. Now, the first law. If the body is at rest or of uniform motion, if body is at rest or of uniform motion, it remains until it or of uniform motion, it remains in that state. It remains in that state until an external force is applied. Until an external force is applied. Now, let's suppose F is, we now know, is ma. That is same as m dv dt. This is actually an external force. This one. Now F is 0, suppose, here as it is given. So m dt dv dt is 0, implies dv dt is 0, implies v is constant. That constant could either be a 0 or some particular value, but it won't change. This constant is 0 or a particular wait a minute, particular value. So the first law has been discussed. Now come to the third law. Now this is the body of mass m1. This is the body of mass m2. This is the position vector of r1 with respect to 2, whatever you say. And this is my coordinate axis. This is my x or y. Okay, let me write it. X, y, or wait, just a minute. It is looking like, now this is my y and this is my z. Now this position vector is r1. This position vector is r2. And this is the resultant. We have already done this. So r1 with respect to 2 is r1 minus r2, or the other way around, or r21 is nothing but r2 minus r1. Therefore r12 is minus of, sorry, wait a minute, here it is equal to minus of r21. Next, R12 modulus, the length between these two, will always remain same, 2, 1. And the position unit vector R21 is minus of R12, either way. Now let me show you something. As you have seen in class 8 and 9, the gravitational force between them, F, is directly proportional to the product of the masses and inversely proportional to the square of the distance between the two. Combining them, F is directly proportional to m1 m2 upon r square. Now, removing the proportionality constant, F is g m1 m2 upon r square, where g is 6.67 into 10 to the power of minus 11. Then this is g. This has a value of Newton. This has meter square. This will go there, and this is kg square. Okay, I think it is 12. Wait, fine. Now let me write it in this. Now let's see. We had these two bodies, right? We had these two bodies. This one and this one. This was m1. This was m2. This is position vector we saw was r1, and this one was r2, and this was r12 or r21, however you want to do it. R2 with respect to 1. So this way. So now the force on 1 on 2 due to 1 is g m1 m2 upon r21 mod square r21 unit vector, and F on 1 due to 2 is g m1 m2 upon r12 mod, sorry, this r12 unit vector. Now suppose I want to express this in terms of this. So now this will be g m1 m2. This r12 and r21 mod are same. So I write r21 mod, no issue. And this is minus r12 is minus of r21. So this is minus f21. So, 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 so f12 is equal to minus f21. That means the forces are equal and opposite because of this minus sign. I told you minus sign has a different meaning. This gives me f212 plus f21 equal to 0. Now, further it is on this, on a little bit of discussion using the second law. Using second law to prove third law. Using second law to prove third law. Third law. Now you know one thing very clearly. F12 is dp12 with respect to dt. F21 you know is basically your dp21 with dt, right? Now the point is that if I add them up, f12 plus f21, if I add them up, dp12 upon dt plus dp21 upon dt, taking dt common, this is p12 plus p21, and as there is no external force, as there is no external force, so d dt of p12 plus p21, oh wait, I'm going too fast, p plus p21 is equal to 0. So let me now get some more page. Let me get some more page. Yes, now from this, so f12 plus f21 is equal to 0 implies f12 is equal to minus f21. This is what equal and opposite force. This is the third law, has been proved from the second law. Now we will stop this here. For the next class,